division. Yeah, but yeah. You know what? I started to do that to try to catch a bunch of them. Once you pop them, they just go flying. Dude, and they were going everywhere. They were going everywhere. Yeah, they were going everywhere. So, synthetic division is using.
Wait, Mr. Murphy.
Yes, ma'am.
Were they going everywhere?
Everywhere. So the little googly eye, you pop it off and go pew, and then another one would go off and it'd go pew, and then another one would go off and it'd go pew.
Maybe.
Anyway, just make sure when you practical joke somebody, you're practical joking the right person.
Did you figure out who it was yet?
No, we haven't figured out the googly eyed bandit yet. Not the googly eyed bandit, it's the googly eye bandit. I had a lesson in my speaking of that today. Using coefficients quickly is kind of the way that I look at this. When you're using synthetic division, all you're doing is using the coefficients. Okay? It's nothing more than adding and multiplying. Adding and multiplying. What synthetic division is going to allow us to do is to find remainders. It is going to allow us to do substitution. It allows us to even factor, if you remember that as you were going through from last year, factor higher order polynomials. Synthetic division is one of the most, I don't want to say economical, but the least time restricted process of factoring. Thank you. I forgot what the word was. Efficient. One of the most efficient ways to no, I'm old. Oh yeah. So I'm going to use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. There really is only one rule for synthetic division. And that is, you divide by the zero of the term. If my term I want to divide by is x plus 3, what's its zero? Negative 3. I always use the zero of the term I'm dividing by. Okay? Always use the term that always use the zero of the term I'm trying to divide by. So if my term was x plus 4, I divide by negative 4. If I'm using x minus 6, I would use positive 6, and so on. So as you're using synthetic division, you take the zero of what you want to divide by, and you put it on the outside. And then you're going to draw...
Wait.
Take the zero of the term. Remember we had zeros and we had terms? The zero is this, the term is that. And now I'm just going to pull the coefficients out, including any placeholders for any of our missing descending terms. So what's the coefficient of x to the fourth? 1. Is there an x cubed? What do I put?
0.
Then?
Negative 10. Negative 2.
You'll remember it in like 30 seconds. And then you'll realize, oh yeah, this is so easy. So the first thing you do once you set up all of your coefficients along with any placeholders, don't forget the signs. That's something very simple that people will forget. If it's a negative, just make sure you put a minus there. The first step is to drop the 1. Now you multiply the negative 3 times the 1. What do you get? Negative 3. Now you add inside the column. What's 0 plus negative 3? Negative 3. We multiply again. 9. Add. Multiply. Add. Multiply. Add. 1. We're done. What's that?
If it works.
If the reason that it would wind up being 0 is if x plus 3 was a factored term of x to the fourth minus 10x squared plus 2, or minus 2x plus 4. If it isn't a 0, then that means that you'd have to go and try something different. We did that a lot with the factor. Remember we had to do the plus minus of all the leading coefficients divided by all the plus minus leading tail coefficients. So you could wind up sometimes when it was 4 and 36, you can have a whole bunch of them. You might have to divide by halves and stuff. But once we started doing this in Algebra 2 last year, you guys got really good at it and saw how fast it was. So what this basically just did was told us that this whole thing divided by x plus 3 equals x cubed minus 3x squared minus 1x plus 1 with the remainder of 1 over x plus 3.
Why wouldn't it be x?
It drops it a degree. Each time you synthetically divide by one term, it drops a degree. Was, hopefully. Another thing that it allows you to do is if you're we'll talk about that when it comes up. Shall we do another one? Let's. Enthusiasm. Another thing we can do, like I said, is use it for factoring. So what this is asking us to do is to take the terms of x minus 2 and the term of x plus 3 and show that it is a factor of the function 2x to the fourth, 7x cubed, minus 4x squared, minus 27x minus 18. I know, it's painful. This is how we're going to show it. In order, if these guys are factors, your last digit will be 0. That's all it is. So we start with, well, what's the 0 of x minus 2? 2. 2, 7, negative 4, negative 27, negative 18. If I get a 0 at the very end, it's a factor. If I don't, double check. Because it's telling you, show that they are factors. So you should get a 0 here.
Like, would you theoretically possibly be like, show that there are factors, but if there could be something?
Yeah, and we'll get to that. I'll get to that here in a couple minutes. Okay. Yeah. Because what I'm saying here is, when you're looking at factoring, when you have a fourth degree polynomial that has 5 terms, there's no way of grouping it to break it into smaller chunks to factor out. So that's why you had to use the factors of the tails to use synthetic division to find some factors, because then it breaks it into easier things to factor. So just drop and go. 2, 4, 11, 22, 18, 36, 9, 11. 11, right? Yeah. No, 9. 9, 18, 0. Yay! We win! So that means that 0 minus 2 is a factor of 2x to the fourth and so on. Now, here's the other thing. Let me ask you, if you know that something is divisible by 6, what else is it divisible by? 3 or 2. So if I look at 12, if I take out I can divide it by 6, which means I can divide it both by 2, or I can divide 12 by 3, and it still works. It still means that 2 and 3 are both going to be factors of it. Okay? So if this one worked, I can check it again right away with the next one. Because it should still be a factor of it. So I just go again. Drop the 2. 6, 5, 18, 15. Oh wow, look at that. We win. Yay. So right now that tells you have 2 terms. You have x minus 2, x plus 3, 2x squared plus 5x plus 3. And that last term is something that's broken down into a trinomial, quadratic, which you should be able to factor by hand. What times what is 3? Excuse me, what times what is 6 They add together to get 5. 2 and 3. So you could factor this further and go 2x squared plus 2x plus 3x plus 3. So your final answer, the whole thing being factored out, would be x minus 2, x plus 3, 2x plus 3, and x plus 1. That's what synthetic division allowed you to do last year by breaking down the upper degree polynomials into easier chunks to work with. Okay? It works out the same. I. Go ahead and turn that off. You can put it away for purpose. Cool. Yeah. Things. Let's do. Wait, what? What I did here is I did factored by grouping. So this is a 1. But you got GCFs.
Okay, so
Let's do another one of the. What I want to do here is show you another thing. You could factor a polynomial given that you know is 0. What this says here is that f of k equals 0. That means that k equals -2, that is a 0. So if k equals -2 is telling you that's the 0, what's its term? X plus 2. If it says k is 10, what's its term? Very good.
I said 2.
So what I want to do is I want to look at this one. I want to look at number 41 here. And I want to use synthetic division to factor it out completely, given that I know one of the zeros. If I know that one of the zeros is 10, 1, -12, 12, 80. If I know that is 10, that means its term is x minus 10. So one of the terms of the factored form of that big cubic function will be x minus 10. What I need to do is figure out the other two parts. Well, that's where synthetic division comes in. So drop the 1, 10, -2, -20, -8, -80, and 0. Yay! Well, we knew it was going to work because it said it was going to work. Right? So now you're left with x minus 10, x squared minus 2x minus 8. Every time you use synthetic division, it drops a degree. What times what's -8? You add together, you get -2. Very good. So you get x minus 4, x plus 2. So your 3 zeros are 10, 4, and -2. What would this look like graphically? Where are your zeros again? Hi!
Hi,
What's shaking, Bacon?
you guys doing anything?
We are doing synthetic division.
Remember last year when my overhead went upside down?
Oh, did it happen to you
And
again?
fixed it? No, but it just happened to Staffstrom. And she's trying to fly people down in the hall.
I'll get it, no problem.
Okay? You want me to stay here and guard the troops?
Can you teach us math first?
Sure I can.
Yeah, no, I'll wander over there real quick.
Let's just do our homework. Yeah.
Okay, start on your one.
Here, do this one.
Yeah, do that one too.
Uh,
Look at that, he can actually do things with this smart board. My dumb boy, you can
Did-
beat on it with a sledgehammer. Nothing.
X minus 2.
All right, let's see.
I'll do it for you if you want. No, can I do it? It's not special.
Can Jack do it?
I asked first.
I don't care. Fight over it. Race. See who's
They'll
faster.
sell
Wait,
points
whoa,
closer.
Hold on, stop.
Race.
Wait. Here.
Life's not fair. Get over it.
We both, right?
Yes, you go.
Whoever gets it first wins.
Wait, how?
Nice handwriting.
I was racing.
You're not gonna have enough room.
Okay.
Winner, Jack.
I need to because this. Kitty, what happened?
I just didn't really want to do it anymore. I have it on my paper, but
You were too scared I was gonna beat you. What if I did it wrong?
Take your time. Pressure. Oh.
Are you sure that's right?
Ma'am. Ma'am.
No, wait, I know.
Is that right?
I got the right answer. Next
Hey!
There we go.
Boo!
No.
No.
13 plus 1, there you go.
You
Oh, now what do you do?
Oh,
What do you
right.
do now, teacher?
What are you doing?
I'm writing. No, I messed up.
Oh, I was saying actually.
Well, you have to do step by step, Katie. They don't know how to do this.
Wow. What'd you do? Whoa. Can you go back? Yeah. How do you factor? How do you factor?
Thank you.
I was
Thank you.
waiting.
Yeah, you're.
Yeah.
Just talk us through it too.
Yeah.
I learned so
I'm
much.
trying to think if there's any other really crazy. I honestly don't think there is. The things that you guys are looking at today work out to be. Oh, you missed all the fun.
Oh man.
Damn.
Boo.
Boo.
Get out of here.
So August.
Peter. Okay, come on.
Let's see. What did I have you guys doing?
20 through 36 are even. 45, 46, 49, 50, 51, 57, 59, 76.
Oh, this could take you 20 minutes. If you take a look at real quick at number 45, number 45 is saying using synthetic division to find each functional value. Basically, you substitute in that value, and whatever number you get left over is as if you just used direct substitution. Synthetic division works the same as direct substitution. It's just a heck of a lot faster. Okay. Let's see. One. Yeah. Go ahead and do it. I don't think it's gonna mess you up. Okay. I think to be honest, I think the one that might take you the longest to do is going to be 76, because they're giving you one term of a 6th degree polynomial, and they're asking you to factor it fully. So you might have to use synthetic division like 4 times. Oh no, it's so scary. I hope you do okay. That was for you. It's been quite a while.
Remember, it's like you were in